Hello, I'm Michael Firth, Product Marketing Manager for Texas Instruments Integrated Motor Drive Products. And today I'm coming to you from Kilby Motor Labs, our advanced R&D center for motor control and motor architectures. I'd like to spend a little time today talking about the specs and the characteristics to look at from a thermal perspective when selecting an integrated motor driver. Let's take a look at the first slide. RDS-on is by far the dominant factor to consider in terms of thermal performance and efficiency on an integrated motor driver. RDS-on is typically spec'd at room temperature. The thing you need to take into account is that your design, when actually operating, is going to run at a much higher temperature. So that 25 degrees C number, while a good figure of merit in terms of comparing one device to another, is not the right number to look at on your thermal calculations. You need to look in the data sheet, look for the higher rated number, typically plus 85 degrees C, and use that number in your calculations. In addition to temperature effects on RDS-on, you need to consider the gate drive voltage. When you're operating off of a battery or at low voltages, many times the gate drive strength, so that's the turn on of that FET, the strength of that actually degrades, and so your RDS-on is going to increase. So consider that in terms of your design. If you're operating at a low voltage or a battery, make sure you've got enough gate drive strength to keep that RDS-on on. Now the other factor that affects the efficiency and thermal performance are the switching losses. These integrated motor drivers today are all switch-based, so they're fast PWM edges. The energy loss during the switching can be a dominant factor in your overall thermal efficiency. So make sure when you take a look at these switching losses, the switching frequency, that that's factored into your thermal equation also. So we talked about the creation of the heat, right? This is the dissipation on RDS-on and the switching losses. The other factor in thermal performance is how well you can get that heat out. And that turns to the package characteristics and also your board layout. So let's take a look at this next slide. Got an example here of a typical power pad at Texas Instruments. And the way that this device gets the heat out, this package gets the heat out, is through the actual board. So there's a thermal plane that is soldered to the ground planes. And all the heat that's generated on that IC, or the majority, is dissipated through those copper planes. So that means if you don't have good layout in terms of thermal, right? If you don't have adequate copper, the right percentage of copper in the planes, you're not going to get as good a thermal performance. So it's very critical that you make sure from a thermal perspective that your layout can handle that heat. The other characteristics of that package are the package itself. How does it get the heat to the thermal pad? How does it get the heat to the top of the power pad? And there's a number of characteristics in the data sheet, or specs I should say, that'll dictate that. So you need to take a look at things like theta JC, theta JA to determine the efficiency of that package. So in summary, when selecting an integrated motor driver, consider the RDS-on, the switching losses, the thermal characteristics of the package, and your board layout to make sure that your design can handle the current that you're trying to drive and you don't have any issues in terms of overheating. I'd like to thank you for taking the time to watch this video, and if you need to find any additional information or have any questions, please take a look at the following URLs.